Iman International Schools. Knowledge for future.
Good morning, students.
Good morning, Iman.
Today we are going to be introducing you to some of the apparatus in the lab, and then we'll conduct a simple practical to distinguish between acids and bases using different indicators. So we are going to start with the introduction of the apparatus and reagents we have in the lab. So let's start from this point. We have this. This is our desiccator. It is used for drying substances. You see the way you open it? And you close the same way. You place the substances to be dried and you place a drying agent. And gradually, the substance will be dried. We have our measuring cylinder for taking in liquids of different volumes. This measuring cylinder can be in glass form like you have seen, and it can be in plastic. But this one is in glass form and it's of different volumes. We have the gas jar. Anytime you are producing gas in the lab, this is what you use to collect the gas jar. We have the watch glass. This is used to observe whatever specimen or reagents that you are giving in the lab. We have the phase 2 funnel. This is used to add in acids or liquids intermittently when the reaction is going on. Phase 2 funnel. We have the funnel. It can be glass like this one. It can be plastic. This is used during titration, filtration, and other reactions to add in liquids into specific containers. We have the flat bottom flask. As you can see, it is flat and can stand on its own. Yes. It is used during reactions too. We have the distillating flask. This is used during simple distillation. Now if we remove this handle, assuming the handle is not there, it can stand on its own. We call this hole round bottom flask. As you can see, the bottom is round. This is one of the commonest you can find in the lab, the beaker. We have beakers of different sizes and plastics. It is used for storing in, for collecting, for keeping any liquid we have in the lab. This is the volumetric flask. It is also of different sizes. This volumetric flask is used for preparing standard solutions in the lab. It could be, like this one is of what? How many mils? 250 mils. So we have that of 500 mils, we have that of 1,000, 2,000, as the case may be. The next is the evaporating dish. This is what we use in boiling off any liquid in the lab. When we want to boil, we want to heat, this is the evaporating dish. This is the wash bottle. Distilled water is filled into this and you just press. Whenever you're washing any apparatus or when you want to add water into any solid to dissolve it, this is what you use. Now we have the spatula. Can be of different sizes, different lengths. This is the spoon in the lab. You use this to scoop in the solids. You don't use your hands because you don't know the nature of those chemicals. They can be corrosive. So you use this spatula to collect them and pour in wherever you want to. Maybe when you want to weigh, this is the spatulas to use. Now this one is the retort stand. This is the retort stand. We use it during titration to clamp on our burette and titrate on the base. So this is the retort stand. At this point we have our tripod stand. You can see the legs are 3. That's why they call it tripod stand. With this, we use it for heating. You can place your Bunsen burner. This one is called the Bunsen burner. And then you heat from there at this point. Now let's come back to this place. While you're heating, you notice that there could also be fire outbreak. Now, in case of fire outbreak, close to that fire point, there will be a bucket of sand to quench fire in case of emergency. You pick the sand and you pour onto it to quench the fire. We also have the fire extinguisher, which you can also use, uncork it and press it so that you will quench the fire in case of fire outbreak. Now we have this. This is our test tube rack. This container, this blue one, is a test tube rack. It is used for holding the test tubes in place. While these are the test tubes of different sizes, the boiling tubes, the test tubes, these are the test tubes. Now this is a test tube holder. While you are heating, you are not expected to pick it with your hands. Instead, the test tube holder is supposed to be used to clamp it, and you turn it away from yourself and from other people while you're heating. Let this point not face you and let it not face another person. So you boil. This is our googles. You use this for protection when you are heating gases that the flames or the lights are very dangerous. You use this one. And this one also, you use it while you're conducting experiments that you need to heat to forestall any eventuality of anything spitting from there into your eyes. Used to protect our eyes. Now we have the burette. This is a 50 mils burette. It is used during titration to collect in the acid, and from here the acid can be used during titration. Some other things like chemino for during redox titration can also be collected in burette. We have the rod stirrer. This is what they use to mix in the liquid, two liquids, or a solid in a liquid. You use this to stir it and mix it, not with your hands. We have the pipettes. It is also used during titration to collect the base. Now, this is a 25 mils pipette, and this point is where the 25 mils will do. You suck in using your mouth, and while you suck in, until you get to the point, close it with your hands, and then transfer it to another container, perhaps a conical flask. These are the reagent bottles. We have two reagent bottles here now. One is the transparent one, while the other one is the amber colored reagent bottle. The difference is that this amber color is used to put in substances that do not absorbs light, sunlight, and react with them. Anything that sunlight is going to deteriorate, we use this one. Something like silver nitrate, we use this to collect it. While this one can be used to store in any salt or dilute acids. Especially dilute base, we use this because this has a rubber cork. If it is a glass cork, it will stick into it and will not be opening again. This is the dropper. We use this to store in our indicators because you need to put them in drops. So this tip will help you to put them in drops, one after the other. It controls the drops. Instead of it pouring, you'll be able to count the drops and how many drops you want. Now we have the separating funnel. When you have two or more liquids of different densities, you use the separating funnel to separate them. Let's assume you have water and kerosene. Between water and kerosene, which one is denser? Water and kerosene, which one is denser? Are you sure? Yes. We'll see that when we get to this point. Now we have the final one we are going to be using is the fire blanket. In case of fire outbreak and it has begotten your clothes on, you use this to wrap it to stop the fire from spreading. So this is the fire blanket. Now, all these things that we have mentioned are just few of the apparatus that we have in the lab. You have to get used to them so that by the time you start conducting your practicals, you don't need to be thinking of what is the name of this or what. The moment the teacher says, get the test tube, you already know the test tube. Get the conical flask, you already know the conical flask. So let's take it once more now. If I lift, you will tell me the names of these apparatus.
Okay, ma'am.
Can we start now?
Yes. Desiccator. Measuring cylinder. Gas jar. Wash glass. Still funnel. Flat bottom glass. Destinating funnel. Flats. Destinating flats.
Again?
Destinating flats. Beaker. Volumetric flask.
This group?
Volumetric flask. Evaporating dish. Wash bottle. Spatula. Retort stand. Fire extinguisher. Test tube holder. Googles. Breasts. Sarah. Pipettes.
Let them say it, Iman.
Again?
Reagent bottles. Dropper. Separation funnel. Fire baguettes.
Thank you very much. Clap for yourselves. I will be asking you questions on their uses in our test and classwork today. So our next practical is going to be a very simple one. Down here in the lab, you will notice that most of the chemicals are colorless. Though we have some that are colored, but most of them look colorless, and you can't even differentiate between one and the other. Now, one of the commonest of them is the acid and the base. Both of them look colorless. Like this is like the water. That is why one of the rules in the lab is do not eat or drink anything in the lab, because you don't know what you are consuming. It might look like water, but it is not water. Now, how do we differentiate them to know that this is an acid and this is a base? Now, we are going to be using 3 indicators here. This is the litmus papers. We have the red litmus paper and the blue litmus paper. Now, we also have the phenolphthalein indicator. We also have the methyl orange indicator. Now, I will tell you the colors so that by the time we are using it, you will tell me which one is an acid and which is the base now. Now, if we use blue litmus paper, an acid is supposed to change the blue litmus paper to red. An acid changes what?
Blue litmus paper to red.
Now, if we are using the red litmus paper, a base changes red litmus paper to blue. A base changes
Red litmus paper to blue.
again.
Red litmus paper to blue.
Now, if we are using this phenolphthalein, put 2 or 3 drops of this phenolphthalein inside the acid and also into the base. Now, in an acid, the phenolphthalein is colorless. Again,
The phenolphthalein is colorless in the acid.
The phenolphthalein is colorless in the acid. But in the base, the phenolphthalein is pink in color. Pink in color. What's the color of phenolphthalein in base?
Pink in color.
Now, for the methyl orange, this is another common indicator. The methyl orange in an acid is also different when you add it into a base. The methyl orange in an acid is red in color. What is the red color of methyl orange in acid?
Red in color.
Now, in the base, the methyl orange is yellow in color. What is the color of methyl orange in base?
Yellow color.
Now, let's start and we'll now. Now, you can see I labeled my test tubes A, B, C, D, E, and F. Now, it means that A and B are either acid or base, C and D, acid base. E and F, acid base. But we don't know which one is acid and which one is base. So we are going to identify them now. You take a strip, just a little of it, don't use the bunch. Take a piece of this red litmus paper. You also take that of blue litmus paper. Now you don't know which is which now, but we want to know. So I will dip the two of them. While you're conducting this experiment, it is best you are even wearing your hand gloves. Now you have your acid and your base. We want it to touch these litmus papers, and we want to see what color changes we will be having. Now look at it. Which of them changed?
Blue.
The blue. So this is what chemical now? Acid or base?
Acid.
Because it has changed the blue litmus paper to red. So we keep it. Now that means we still have our red litmus paper now. We have identified one. Now let's go again. Now this is the second one we want to identify too. Maybe it is same acid. Who knows? Now what did we observe? The red has turned to blue now. So what does it mean?
Base.
Okay. We had identified this. A as our acid, B as our base. Now let's use the next one for this. Can we pour a little of it? Because the moment we pour it, now a little of this, our C now. Do you notice any color changes? No. That means this is what?
Acid.
Acid, because it is acid that is colorless in phenolphthalein. Now the next one, what do we notice?
Base.
What is this color?
Pink.
That means we have identified these two. This is what?
Acid.
This is what?
Base.
Okay. Now this one too. Let's also scoop a little of it. This is our methyl orange now. What color is this?
Orange.
Is it orange or yellow?
Yellow.
Okay. So this is our what now? Which one will give us yellow in methyl orange? Then this. What is this color?
Red.
Now let's see. Tell me which one is my acid and which one is the base.
This one is acid.
And this one is
Base.
Oh, you said this one is acid before.
No.
Okay, so the red one is the acid, while this yellow one is the base. Because the color of methyl orange in an acid is red, the color of methyl orange in a base is yellow. So we have our acid base. Now you have now differentiated the acid and the base. This is your acid according to the litmus paper. This is the base. This is the acid according to the phenolphthalein. This is your base according to phenolphthalein. This is our base according to methyl orange. This is our acid according to methyl orange. So you already know that these are no longer water, but they are what?
Acid and base.
Now you conduct your own experiment. I'll also label them like this and put them. So you are going to identify which one is your acid and which one is your base. Do you understand what we have just done now?
Yes.
Thank you very much.